I'm Ted. And I'm Zippy. Have you seen us in the data science tutorial videos? If not, check us out. Oh yeah, there's the old man as the first player. Wow, there's a lot of information here.
Yeah, we have 8 characteristics in total for each player. We have their age, gender, health status, strength information, and whether they have played the game red light, green light before.
Now, let's install 3 packages: Tidyverse, Data Table, and Dicer. You need them to run the analyses. Copy that.
I guess we load the dataset that Zippy found next.
That's correct, Bruce. Then, let's use Dicer to create a consensus cluster by selecting 3 clustering algorithms. Done! Look! I've made a heat map showing the 4 clusters: C1, C2, C3, and C4. Why don't we use data science to predict the results? Isn't there something called survival analysis? Do you mean time to event analysis, Zippy? We can use this method to find out the time for a group of individuals to experience an event of interest. That sounds about right, Teddy Bear. There are 4 shapes, and so there can be 4 groups of players. Let's hurry up, Teddy. Let's find out which shape is the easiest. Okay, don't worry. We can use the Kaplan layer estimate to measure the fraction of players who survived for a certain amount of time. This is to show the average view of the population. We can define survival time as the time starting from the beginning of the honeycomb challenge to the occurrence of the event of interest. Players either survive or die. Now, let's install 2 packages, SurfMiner and Survival. This dataset has 4 columns: player number, shapes, dead or alive outcome, and time to the end of the game in minutes. That's right. You can then use the surfFit function to calculate an estimate of a survival curve. Copy that. Then I can use the ggsurfplot function to generate a graph. Yes, try that. Done! So, there are 4 lines on the survival graph. That means those lines represent the 4 shapes. That's correct, Zippy. We can see that players who selected the star shape have the highest chance of surviving and winning the game. We can use the social network analysis technique to identify patterns of social interactions. We can use graph theory to understand social structures. To build network graphs, we need 2 components: players and relationships. That's right, Zippy. A social network graph contains dots and lines, whereby the lines connect the dots. So the dots represent the players and the lines represent the relationships. Now, let's install a package called iGraph. Okay, let me Google. Done! Now, you can bring in your dataset, Zippy. Got it! We have 2 datasets, one for the edges and another for the nodes. What are edges and nodes, Zippy? Well, each node is a player, and the age represents whether players appear together in a scene. So players that appear together more frequently have more chances of communicating and therefore are more likely to choose each other as teammates of the tug-of-war game. That's right, Teddy Bear. In this example, we can see that Ali and the old man appeared in 5 scenes together. Now let's create the iGraph object. We can use the GraphFromDataFrame function, which takes the edges and nodes. Got it! We can visualize the network using the plot function, and we can create a new color variable to show nodes in 3 colors. That's a great idea, Zippy. Let's use red for players in the gangster group, gold for player 456 and his friends, and green for the other players. Okay, done! That looks great, Zippy. Look, the social network analysis shows that the head gangster, loud woman, and doctor interacted more with each other in red. Yeah, and in gold, player 456, player 1, Ali, the girl, and the scholar had a lot of interactions with each other. Which is why these players were all on the same team for the tug of war game. Can we use data science to predict what it takes to win the marbles game? We can use decision tree analysis, a type of supervised machine learning, to predict whether a player will win or lose the game. Great idea, Zippy. A decision tree is drawn upside down, with its root at the top, called the root node. So, the root is split into branches based on a condition. In this case, the condition is monthly income above or below $260. And at the end of a branch that doesn't split anymore is the decision or leave. In this case, whether someone is dead or alive. Let's start growing a tree, Zippy, to find out which players win the marbles game. Copy that, Teddy Bear. Here's the marbles data set. It has information on age, occupation, marital status, education level, savings amount, car or house ownership. To create decision trees, we need the rpart package. Got it! Loading and done! Let's create the train and test datasets by splitting the data 80-20. Okay, done! Now we can generate the model using the rpart function. Then we can plot the tree using the rpart plot function. Okay, done! Wow, this looks great, Zippy. Well done! At the root node, we can see that the overall probability of surviving is close to 0.5. That's right, Teddy. One player wins, another loses. Then, if a player's monthly income is less than $260, the probability of surviving is 0.26%. We can follow the decisions in this tree to find out if a player ends up surviving or dying based on the conditions. That's right, Zippy. Come, let's watch the marbles game. Teddy, what data science techniques can we use to predict which players would win this game? Teddy, don't each player have their strengths and weaknesses? Yes, and we can use Cox regression to predict how these characteristics affect the outcomes of the game. Cox regression? Is that the same as the Kaplan-Meier time-to-event analysis we did in the episode 2 of the Honeycomb Challenge? In survival analysis, we can use parametric or non-parametric techniques for modeling the survival function. The Kaplan-Meier is a non-parametric estimator, meaning that it does not rely on any assumptions and the data does not have to follow a specific distribution. Does this mean that Cox regression is a parametric test? Actually, Cox regression or proportional hazards model is a semi-parametric test. It is not fully parametric because even if the regression parameters are known, the distribution of the outcome remains unknown. Oh, I see. This means that Cox regression has a lot of flexibility and allows us to model the impact of each player characteristic on survival. That's right, Zippy. These characteristics are called covariates. Here's the glass tile dataset. We have information on age, sex, stability, which is like balance, amount of calories in the last meal, and so on. Looks interesting. We also have the glass assessment ability variable. Yes, Teddy, this indicates the ability of a player to determine whether a piece of glass is made from regular or tempered glass. So, players who work in the glass industry have an added advantage here. Cool. To run Cox regression, we need 3 packages: Survival, SurfMiner, and GT Summary. Let's fit a Cox model using the surf function to create the object and the CoxPH function to fit the model. Okay, done! Wow, the results look a little messy. That's right, Zippy. Let's clean the results using the TBL regression function in the GT Summary package. Okay, done! This looks much better now. So, based on these results, It looks like being a guy is associated with having a greater risk or hazard of dying. That's correct, Zippy. On the other hand, having a higher glass assessment score is inversely associated with death. This means that players who are able to distinguish between regular glass and tempered glass have better chances of surviving. That makes complete sense, Teddy. Wow! We can also plot the output as a forest graph using the ggforest function. Done! It's so easy, isn't it, Zippy? Now, you can see all the results in a graph form. That's right, Teddy Bear. Come, let's watch the glass tile game. Let us know what you think. Bye for now. See you next time.